Hello and welcome to episode 3 of a 3-part video series on using Maxim's MAX32630 Featherboard to drive an OLED display. If you haven't seen parts 1 and 2, you may want to take a look at them now. In the first 2 installments of this video series, Greg showed how to assemble the hardware and how to configure the development environment and load the demonstration program. In this episode, Greg will take you line by line through the demonstration program, and by the end of the episode, you'll see how to modify and customize the file for your own use. Here's Greg.
So as we scroll down, you'll see the includes include Mbed.h. That's the main Mbed library. There's a ton of code behind that takes care of all the hardware abstraction to make your lives a lot easier. Then we have the MAX32630FTHR.h file. This is a header file for the Featherboard library that has some nice helper functions to make configuring the board a little easier. Next, we have the Adafruit SSD1306.h file. This, as you might expect, is the header file for the OLED library. And then we also have the USB serial.h file, which includes serial functions. Going down, you'll see that we're instantiating the MAX32630FTHR library as Pegasus. And here, you'll notice we're passing a parameter that tells the board what voltage to use for the header pins. This is important because the MAX32630 microcontroller supports dual voltage I/O, and the MAX32630 Featherboard is capable, has that ability as well. So we need to specify which voltage we want to use for the feather wing. In this case, the OLED feather wing, which is a 3.3 volt device. So in this case, we're setting the default voltage for the header pins, the VIO, to 3.3 volts. Next, you'll notice we're declaring an I2C bus that will get used for the display. And here you'll see we've got 2 serial ports. The first serial port is the DAP-Link port. This is where we send our debug messages through the SWD cable. And the second port is a virtual serial port over USB. That's also available for messages. After that, we do declare the 3 LEDs, the red, green, and blue LEDs, so that we can tie those to the buttons. And we declare the button inputs. And here you'll see a note that describes what I mentioned a little bit earlier. Analog inputs 0 and 1 have internal dividers, so they can tolerate 5 volt signals. The full scale range on the other 2 is 1.2 volts, which is the internal reference voltage. And actually, you'll notice we call out analog input 4 and analog input 5 for analog input 0 and 1. Technically, there is an analog input 0 that is the input without the divider. But since we'd like to take advantage of the 5 volt scale, we're calling out inputs 4 and 5. Next, we're going down into the main function, which is what will happen after all the initialization is complete. Here we're sending out messages over the two serial links, the debug link as well as the USB serial link, and we're initializing the LEDs. Then we go through we wait a little, time for supplies to settle before we start initializing the display, and then we call the display setting, and we pass the I2C by reference to the library. After that, we can print a few messages to the display and then go into our while forever loop. Here, we've got a fixed delay. We check both of the serial ports for characters, and then we assign the LEDs to the buttons, and then we we clear the display and send a new message to the display, which includes the analog inputs, the buttons, and the character if received from the serial ports. So not a whole lot going on there. You can see the libraries make a lot of this very simple, keeps the main routine fairly clean. And at this point, you're welcome to go in here and modify to your heart's content. And after that, after you've made your modifications, the rest of the steps are just what we've gone through before. You can go up and compile and drag and drop the files back into your board to test it out. I should also mention that the Mbed IDE does support revision control. So you can also commit and eventually publish these files to share with others if you choose. There's a lot of flexibility to go in here, but this is basically just pointing you in the right direction to get started with the MAX32630 Featherboard.
So that's it. You can see how easy it is to customize the program for your own use. Now be sure to stay tuned for more tutorials and videos from Maxim's Applications Engineering Group. See you next time.